and you have elements, ZH, that correspond to a row vector with p elements. At the same time, you have the image extrapolated and with this vector u, and you can combine the original one, the m pixels with this new information in a new data set, and you obtain the image segmentation. The algorithm that we propose, this machine learning for image validation algorithm, is based on this idea. We define a function psi that just assesses the performance of a classifier Cj. And we obviously use a training set and a learning set in the classical way. It means that we have to train on the learning sample and to test on the T sample. But what we find, the output of our function is just the prediction error of the algorithm. And it means that we can consider more than one classifier, and we can also combine data and have an idea of how possible is to rank the image segmentation algorithms. And it means that you can obtain this lambda, and you can sort this lambda in an increased order, and you can have an idea of how an image segmentation algorithm works on different images. But obviously, there are some problems. First one is due to robustness of estimated prediction. The second one is, of course, on computational complexity due to large amount of data. And to overcome these drawbacks, we try to use very classical methods, but at the same time we try to go back with some ideas, just like Fisher consistent estimators. What it means that if you repeat the estimation process, we can, on some samples of our data, we can find a particular n that give us the convergence. It means that we can avoid not only problems of robustness, but also computational complexity. And it means that we have to draw randomly without replacement from the new matrix T. It means the matrix with the original pixels and results of the image segmentation algorithm. And we obtain some samples of size n. What's the problem? The problem is that not in the averaging the results and in order to obtain the estimate, but the problem is assessing the optimal size n star. How solve the problem? We consider three approaches, the well-known approach, learning curves approach, asymptotic regression approach, and convergence in probability approach. The idea is to have something that give us some stable results. I skip with the technical detail on learning curves, well known, and automatic asymptotic regression and convergence in probability. But what I would say is that what we are looking for is for this n star. Okay, we applied this our algorithm on considering 4 images. 13 image segmentation algorithms and 10 classifiers, but very, very known classifiers, very not complex, if you want, classifier. As you can see, this is the 4 images, Airplane 1, Airplane 2, Swan, and Tiger, and at the same time, the classifiers are just key nearest neighbor, neural network, random forest. What we use currently. We considered, in order to evaluate the performance, in order to compare ranking, the extended version of the Kendall's Tau, introduced by Hammond and Mason in 2002, and in order to have a measure of the ranking. At the same time, the property of this index is that you have, it's ranged in -1 and +1. It means that you have the possibility to establish how the rank are correlated. It's just like a correlation. And another index is the difference from first, in the sense that if your objective is to isolate something and you need for a good algorithm, what is important is that you have not so much differences among the first 2-3 algorithms. The rest you can skip. And this is the results of the application. In this case, using simply linear discriminant analysis and learning curves in order to obtain N star. This is the original. This is the true best. What is the true best? It's something real near the human rater. And this is the results of our algorithm. In the sense that the validation, but considering all the images. And just to give you an idea of how it works, lambda is considered just like 1 minus the area under curve in the ROC approach, and it means that it's possible to consider just like an error, the misclassification error. And hereby you have the results considering all the classifiers, all 10 classifiers that are sorted by the complexity, and also the result in terms of tau and difference from first. As you can see, you have a lot of many classifiers that work well, but at the same time you have the idea of how the differences in misclassification is. At the same time, you have the idea how the sampling approach is performant. You can see that with the learning curve, you are only the 0.52% of the total amount of data in order to have stable results. Some brief conclusion on this part. The validation of image segmentation is a problem specific as well as a context specific. At the same time, why is important to use an algorithm just like Maliv? What is important to validate something just when you use data coming from measurements. And if the human rater is our benchmark, in a problem just like image segmentation isolation, it's possible just with the Maliv to detect a good ranking to the different segmentation algorithms. And Maliv is often able to correctly detect the best segmented image just with a difference from first just so low. Okay. This is a way to interact with the data coming from measurement and using feasible statistics. Another topic is the analysis of online reputation data. And we know that online reputation is growing up very fast as problem for management, for business, and so on. And in our case, the specific framework is the customer satisfaction from booking.com. And I think that everybody, when we have to choose an hotel or something like that, the first thing to do is to consider review. Okay, and there was in Sardinia, Regione Sardinia, that funded a research project just for analyzing what happened with the review. And the motivation and some research questions that we had is how to consider the influence of a specific review's content on a hotel scoring, how to consider a benchmarking hotel destination services based on a specific review content, how to define a new and more reliable hotel score, different from that booking proposed, and observe how it evolves in time. And also to design a novel hotel search engine based on specific review content. I think you know this. It's something that we see usually. As you know, the total score for an hotel, for example, the total score is used for some items, just cleaning, comfort, position, services, staff, quality price ratio, and Wi-Fi presence, absence, or something like that. But what you have to notice is that in the first item, cleaning, when I give a score, but cleaning what? Cleaning the bed, clean the apartment, clean the bathroom. In the sense that you have some more information that are just compressed in something. Wi-Fi is much more easy in the sense it's quite a presence-absence of something. And at the same time, you can find some words, and if you take a look to the right part, in some words that can condition the judgment. At the same time, you can find the same word in a negative comment or in a positive comment. And if you have so much data, it's quite difficult to synthesize all. But policymakers, managers have to take some decisions and have to have some feasible results, very, very feasible results. And this is the data that we considered. We analyzed 600 hotels located in Sardinia with 66,000 reviews, but with so much comments in Italian and in English, positive and negative comments. And we organized data in 2 data sets with 127 features in the hotel data set with some information on the hotels and some comments on the hotel, some data specific for the hotel, and the comments data set with 41 features. And we investigate this data in the period from January 3, 2015 until May 27, 2018. It means 1,240 days, but the results that I am just presenting is till this date, but we still continue in the sense that it's a project and we are monitoring this, the hotels in Sardinia for this thing. Data preparation. Now data is not coming from measurement. You are not so sure. And you have to clean data. For example, you have to remove stop words. You have to do some data manipulation. You have to merge data in the sense that you have some words that are with similar meaning that are assigned to macro words. And at the same time, you have to join the results of all the macro words that are composing each comment in order to obtain the bag of words. And it means it's just in this picture you have just a sort of a synthesis of what's happening. And the final data set is in sense of presence, absence, or something. How to analyze this data? We tried to, with so many classifiers, but at the end we, just with a little modification of a simple naive-based classifier, we had to reconduct the log likelihood of for a specific review R, and for each word of the bag of the word, just in a presence, absence of the word. And at the same time, the same thing for a specific comment, it's considering the log likelihood, it's possible to organize all in such a way and obtain some feasible results that can be manipulated in some way in order to give much more information for non-specialists, but for sometimes that have to take decision. And it means that all is in a presence-absence approach. This is just as an example, the probability and the likelihood ratio table. It means that you have the probability of a single word, assolutamente is Italian, C is in English, but you have the probability of the word given if a negative or positive comment. At the same time, you can work on the log likelihood of the presence, absence of a word, and you can combine the results, and you can, as I will show you, extrapolate some things. What's the problem? The problem is to estimate a threshold parameter tau in order to decide when something is classified negative or when some word is classified positive. And we obtained by too much simulation, so much hard work for our computer, but we estimate by cross-validation, with the objective to simultaneously minimize the type 1 and type 2 misclassification errors. In our results, we have this tau, but this is the tau till 2018, and we are sure that this tau will change when we update data, and it's a way to have a dynamic system. The same thing, the same approach is used for the R, the set R of the R words composing the review R. Okay. It's just to show you how just a benchmarking for this naive-based adapted algorithm with the other one. But if you are the capability to have very simple results, at the same time you can conduct very interesting ex-post analysis. And it means that you have the word, the macro category. At the same time, these are all macro categories that can become your interest in order to decide what to do. And for example, here you have the position in the Cagliari area of some hotels, and you can see that for a specific item, just a word just like Wi-Fi, you have the positive comments. It means that the time that you find the word Wi-Fi in a positive sense is higher than the negative one. But it is not the same for another area. Carbonia Iglesias is an area of Sardinia that is much with some problems. I think it's the less rich county in Italy. And you have a different situation. It means that you can interact in a different way. But not only. This is the classical way for booking in order to rate something. You have to click on an emoticon for each item, and after we have this translation in a score. And for us, it's not adequate. We propose to obtain something of categorical. Is much more easy for someone to analyze, and the approach is to work on the quantiles of the empirical distributions. And it means that you can classify with some satisfaction classes, and you can have completely unsatisfactory, not satisfactory, potentially good, good, excellent, and you can also obtain the real score, but that are in an objective way extrapolate. And also you can see that if you the results depends depends on the standard deviation in the sense that it's not the same thing to obtain an excellent result compared with the completely unsatisfactory. And it's due to the fact that if you are not satisfied, maybe you are not satisfied for so much things. But if you are satisfied so much time, it's for particular things. But this is a way to investigate the data. Again, it's possible, if you have the capability to extrapolate this with this log-like regression, you can create something in order to follow an hotel for time, and during the time in a longitudinal way, and at the same time you can make some union of some situation or some data. And for example, you can see that in black you have the overall judgment for an hotel, and what's happened with the other, the judgments on the other item, the item that I've composed. What you can see, we have some judgment, some item that, some words that are very, very, very close the overall result. But you have also in the higher part and the low part of this graph, you have also the situation of where some words are so different and so when the time runs, you have that the effect is so strong. What it means? This is the classical propagation effect of a review. In the sense, if you read something, your attention, as if you read something that is in the hotel is not so good for a bathroom, your idea is, the first thing to do is to control, and maybe you are so much strong in the decision if it really is okay or not. In this example, we worked on online reviews content as starting point, and the idea is let the words speak from themselves. This is the message, not something else. And rather simple statistics works well for the purpose. And at the same time, many statistical operational conclusions can be derived from the analysis of online reviews content. The third example is in social media popularity. This time data is it's really quite complicated to analyze. This is Donald Trump, if someone don't know. This is a Twitter of Donald Trump. And this is one of the last Twitter of Donald Trump, in the sense that now he say that my lies and bullshit have contributed greatly to the anger and rage that has built up over many years, have got to start being less hateful, racist, and xenophobic. And or this terrible problem will only get worse. But it is now. And it was Just after the
Are you
election.
going to be tweeting and
It's not Trump. It's
whatever you're upset about, just put out there
So
when you're
it's a
president?
modern form of communication between Facebook and Twitter, and I guess Instagram. I have 28 million people. 28 million
So
people.
you are going to keep it up.
It's a great form of communication. Now, do I say I'll give it up entirely and throw out? That's a tremendous form. I'm picking up now, I think I picked up yesterday 100,000 people. I'm not saying I love it, but it does get the word out. When you give me a bad story, or when you give me an inaccurate story, or when somebody other than you in another network or whatever, because of course CBS would never do a thing like that, right? I have a method of fighting back. That's very tough.
But you're going to do that as president.
I'm going to do very restrained if I use it at all. I'm going to do very restrained. I find it tremendous. It's a modern form of communication. There should be nothing you should be ashamed of. It's where it's at. I do believe this. I really believe that the fact that I have such power in terms of numbers with Facebook, Twitter, Instagram, etc., I think it helped me win all of these races where they're spending much more money than I spent. And I won. I think that social media has more power than the money they spent, and I think maybe to a certain extent I proved that.
Okay. And this is the official apologize. Instead that Evan Williams is one of the co-founders of Twitter, and this is the result. It says that I don't know the parents, Evan Williams' parents, what thinks. But, well, it means that also as community, we have to take into account what's happening. And what we try to do, we try to consider the popularity prediction from Twitter. And since popularity on Twitter defines by making as favorite, leaving a comment, or resharing the tweet. And this is our data. We considered the election campaign, assessment of popularity in social media, and during the USA election 2016 as a case study. And the goals, as you can see, is to analyze the differences between users' tweeting styles, as well as we are interested in understand whether a tweet can be considered as popular or not before posting. It's very, very important. And understand how sentiment analysis could help to improve the performance of a prediction model. Understand whether the content of a tweet is a proxy of social media popularity. And also understand the causal relationship between sentiments and changes in social media popularity. This is the schema, and you have the data gathering from Twitter. It was not so, but by crawling data it is possible, and the data preparation and sentiment analysis in order to have an idea, in order to extract some features, set up the target variable for our purposes, to predict a social media popularity index and to analyze and interpret the causal relationships. I have to admit, I am honest in saying that this social media popularity index is an idea of Claudio Conversano. And I'm very worried. I don't know if Claudio Conversano is just going to candidate for next USA election or is just a candidate in order to be an influencer. But in both cases, I am losing a friend, and so I'm really very worried. Anyway, thank you, Claudio, for... In any case, we had two data sets, the candidate tweet, the hashtag tweets. In the candidate tweets, we considered the 5,000 tweets from Clinton's timeline and around 40,000 tweets from Trump's timeline. And the hashtag tweaks. The hashtag, it means that you have to isolate all tweets that contain the hashtag Clinton, hashtag Trump, and so on. And we obtained this so much data. Gathering data and cleaning data was not so easy. We implemented a crawler in Python, and we monitored the candidates since January 4, 2016 until the day before the election. It means in November 7, 2016. Cleaning. Cleaning, it means that we had to remove punctuations, but we are able to take in account some certain symbols that in a tweet are very, very important. And the feature engineering is just in order to use, to consider these features for building up this social media popularity index. We had frequency of frequent words, emotions, polarity, since something is positive or negative as polarity, and also these punctuation symbols. Well, this is just results of the sentiment analysis. As you can see on some emotions, the behavior is not same. It was not same from Clinton and Trump. And at the same time, also the polarity is not same. And you can see that the emotions show a reflection of the personality of the candidates. But if you consider the polarity, you see that the Clinton tweeted more negative words and less positive words compared with Trump's. But in the lower part of this graph, you can see what's happened with the differences in frequency from Trump and Clinton. And you see that this is for Trump, that you have for negative emotions this behavior, and for positive emotion, a different situation. And for Clinton, of course, you have this situation. Well, it means that in a such way, the popularity is not the same. And how build up a social media popularity index? We organized just setting up a target variable for our classification problem. It's the variable-wise dichotomous variable with R greater than alpha and Y if R is less equal alpha, where R is the number of tweets, retweets, and received by a single tweet, and alpha is the proportion retweet. And alpha is obtained by really so much simulation. The approach, simply a random forest, but of course, we are considering data in timeline. It means that we have to consider recurrent random forest and just what happened for neural networks or other classifier. We have to introduce a parameter WT that take into account the results of the previous classification process. And it means that in such a way is it possible to have an idea of the misclassification error, the sensitivity, and so on. And this is the social media popularity index in the raw index, but at the same time, it's much useful since you are in the timeline to obtain a smoother, just in this case we consider the lowest with the generalized cross-validation, obtained with the generalized cross-validation. And just to skip to the schema, it means that this is a sort of window sliding approach in the sense that we considered 12 weeks in order to train the classifier, and 1 week in order to train the classifier. But in a sliding way, in the sense that if we start from week 2, we have from week 2 till week 13, and after for the learning set, and just week 14 for the test set. Okay. We know also that during some periods, and during these periods, something happened. And something happened for Trump, for Clinton, but for both. What's happened? Happened what they say. And they said that Trump's campaign calls for a Muslim ban. Trump fought with the Pope Francis and so on. For Clinton, maybe you remember the problem with the email and some problem with the security and so on. Okay, it means that you can take into account this, and you can plot this social media popularity index in the raw way with these dots, but also with the smoother. And we can have an idea of how it's working, how it's retweeting, and with the red line, you have the Clinton behavior, and with the Trump line, with the green line, the Trump behavior. It's not the same. But also if you consider these relevant events, if the relevant events are generated by Trump, the popularity is very, very, for Trump, is change quickly, but for Clinton, it was quite the same. Popularity is the number of retweets, the number of times that something go ahead. And for Clinton, you have just a little problem when when there was the problem with the FBI and so on. Okay, very quickly, just the time is running. Of course, it's possible to consider whole emotions, and you can consider a model just like generalized additive model in order to model all emotions. Since the behavior is not the same, it's changed for candidate and for emotion. Okay, our findings are linked to the current phenomena of organized social media manipulation and white populism. Popularity is not the same as populism, the two different things, of course, and it means that this approach cannot be viewed as candidate election prediction method. Even if we have found some recurrency with the popularity and the polls during the period. It's incredible. But of course, it's not can be viewed in this way. And why we think this method, the proposed method is really valuable? It's utilized a combination of classifiers that are extremely flexible. We use random forest, and you know random forest has good property in scalability. It means that you can use changing the amount of data. And of course, you can use this method for other analysis. Just concluding remarks, Chair, sorry. Some milestones. Data only is not enough. Expertise is not optional. Quality of data is a must. What it means, I have reported something for that can be considered for the debate, but of course there are some consideration that we have to take into account more than in the past, since the amount of data is increasing really fast. And combine data with the expertise is fundamental, I think. What do we have and need today? And I've reported some phrases from some colleagues, but at the same time, I think that we have to reconsider too much think about sampling. In sense, all results for statistician on sampling is very, very important, since in the future we cannot only consider the power and speed of technology and computer. And hereby a list of new tasks, if you want, new steps, new frontiers that are in this, I've reported the literature, but the last, human-in-the-loop perspective is something that Doan, he prepared a taxonomy, and I found that the best taxonomy today is that we have the data problem for the Hilda group that prepared. And you can see that you have exact insights from data, building knowledge-based graph, fostering data, software community. It's what's happening. Explore, profile, clean, transform, match, merge, wrong data. But it means that what's about the role of a statistician? In all of this, intervention, it's fundamental that we consider all of these tasks. And if you remember, just finishing, what's happened in the past and what can happen in the future. You remember I think that someone arrived and said, I did a survey. Without a statistician, the statistician will help us to analyze data. Hi, I don't know how to analyze my data. Could you help me? Sure, I'm a statistician. That's what I do, and I have a big heart. And after, who prepared this data? It's a drama. This is the best situation. Let's do a survey. Without a statistician, it's better to call him in advance. And after, data analysis is sometimes relaxing. And also in the educational domain, so much people here are in the educational domain. What's happened with the students? You have a data matrix. Which one of these is the best method in order to analyze this data? A, B, or C? Someone say method A, someone I prefer B, but you can find someone that say, but if you are 3, we can perform all 3 methods without problem, and after we choose. And the teachers say, if you were 100, would run 100 method, why not? And it's the best thing to do is just going up from the window. What it means? It means that this is not parallel computing. This is human parallelism in the sense that you are looking for so much people that have to work on data. It's not good, but just finishing. What I would say, and I think what is important for our group, data can be stressed wrongly. Maggot, sorry for this, not good English, that's but in the informatic jargon maybe. What's important is to combine methodologies, knowledge, and good data. This is the best way for me to produce good recipes and pass from data to information. This is the problem of my title. Problem that we grind data, but information is something different. But someone prefers to charge data. And I know you will meet someone that is a torturer, and what you can say. I think that the only thing that we can say is, please be so kind. If you have to charge your data, at least don't violate human rights. Thank you very much.
Thank you, Franco, for your talk with a large perspective and suggestion. Comments, questions? I do have a question about the the booking review.
Yes.
You put together a balance between negative and positive comments. But words, when you have more complex expressions, misleading expression,
Yes.
how do you manage in this case?
Yes. In fact, the idea to, since a word can be achieved in a negative way and a positive way, what's important with the log likelihood is just to, and with the probability, is just a way to combine it to detect if you have in a positive way or in a negative way with the words. But combining with the other words, the accompanying words, you can detect, you have an help in order to define if you are in a negative way or in a positive way. This
Okay,
is it.
thank you
very much.
Other comments, questions? Okay, thank you again, Franco. I invite here Francesca and Giovanni and Roberto for the closing statements.
We didn't thought about who should be the first. So I'm going to be the first because I'm very quickly want just to express my thanks to everybody here, to everybody who attended, but to the many that worked out a lot for building this conference. And first of all, I would like to thank Roberto because he have chosen the scientific committee. And so it was a very good choice because we work in a way that I think it was fruitful. Also, I'd like to thank Francesca because it was wonderful to work with her. Thank you very much for many details that you can imagine. And also, I'm thankful to the local organizing committee and especially to Mimo, Simona, and Renato that did a great job. So the last thing I want to say is I'm sorry if you feel uncomfortable for some reason I even don't know during these 3 days, but I'm glad if you instead feel comfortable for many other reasons. Thank you all.
It seems to be a long time, but only 3 days, because I started this conference as the president, and now I'm only the past president of cladag. And I would like only 1 minute in order to thank all of you, the participants, local organizing committee, scientific committee, and especially the contributors, especially contributors coming from abroad, that took a very, very long journey for being here. Thank you very much. And I leave the floor to Francesca.
I believe that all of you have well done through the 3 days meeting, and it is my great pleasure that we had fruitful discussions, and we all agree that 3 days is not enough to assimilate all the new and challenging ideas that were presented here. They rather push us to return to our research activities with renovated motivations and useful hints. We enjoyed excellent presentations and active discussions, and this is a good reason to think about having a book of selected papers into the spring series, and also to collect still selected papers for a special issue on statistical and data analysis as a journal on data science. And a special warm thanks goes to Giovanni, Simona, Domenico, and Renato. And it was a common and absolutely unanimous thanks from all the people here, because they prepared and organized such a wonderful conference. They have made this a very pleasant experience. It has been also nice and instructive to visit beautiful places in this historic region. And I want to thank the scientific committee for having done very great work along the preparation, and to all of you for contributing to this conference.
Okay, just some words from Roberto Rocci. Thank you very much, Roberto, for your dedicated time for us, for cladag community. But you have now the past president, and you have to work again. Thank you, Francesca, at the same time, and for this important role and with the scientific program committee. It's very, very interesting, the conference. And Giovanni after. I have to say something to Giovanni after. Now I would say, just recall that we have some, for the cladag community, we have next cladag will be held in Florence 2021 and 2021, and the organizer, the Department of Statistics in Florence, with Carla Rampichini and Grilli and so on. Also, we have the summer school on Robust Statistics Foundation, Recent Development, Marco Riani, and Paganoni, Cerioli, and Professor Atkinson will be the summer school will be held in Milan and on Lake Como in reality, and from 20 to 24 on April 2020. Also, Francesco Palumbo and this group are organizing the next SCDA in Naples 2020. And Salvo Ingrassia in next September, from September 2 and to 4, in fact, 2020, the classical model-based clustering and classification congress. Okay, you will find on our website more information in the future. And for Giovanni, I would say that I can speak on behalf of everybody. If I say that in this Congress, apart of the scientific component, what we found is some humanity, and these fantastic students from the school, San Benedetto School, that prepared the lunch for us. That was very, very, very funny. The young musicians from Scampia. And I was touched personally, since I came from this place. Also the social dinner. It was something from friends, and we had also the possibility to recall to us how lucky we are. Thank you very much, Giovanni. Okay, finished. See you next time. Francesca, la scuola mi sono dimenticato di dire che però la scuola sei tu l'organizzatrice, però vabbè, volevo ringraziare.